Hello everyone and welcome to lesson 2 from chapter 3. Yes. We're looking at pages 203 to 206, adding integers. Now integers are positive or negative whole numbers. Don't forget that. Integers or numbers that we're working with can be counted in infinitely in both directions. So towards the positive direction and the negative direction, infinitely. Okay? So let's define this. Where do we normally see positive and negative numbers? Where do we normally? Well, if you have ever looked at the temperature, sometimes freezing temperatures, they're below zero, and non-freezing temperatures are above zero. So you would see this for cold and hot temperatures. And what would be a math example? Well, you can have a temperature of -3, right? -3 Fahrenheit, or you can have a positive 3, just regular 3 Fahrenheit. Okay. This is what we call additive inverses, when they are completely opposite. An additive inverse, when you add them up together, they will equal 0. So -3 plus regular 3 will bring you right back to 0. And you can see that here. Two integers that are opposites are also called additive inverses. So these are additive inverses. The additive inverse property states that the sum of any number and its additive inverse is 0. You can show that by saying 2 plus -2 on a number line. You see that here? You add 2, and then you take away the 2, and it's always going to bring you right back to 0. Okay? So 2 plus -2, or you have, let's say, our dollar example, you have $2, and then you spend $2, you're going to have $0. In the real world connection, as I said, temperature outside is -5, so -5, that could be Celsius or Fahrenheit. Name the temperature that would make the sum of the two temperatures 0. Well, if it's -5 and I want to bring it all the way to 0, I have to add 5 to it. So I need 5 Celsius. Okay? When you add integers, okay, sorry about that. When you add integers with the same sign, to add integers with the same sign, add their absolute values, and the sum is positive if both integers are positive. Negative if both integers are negative. So positive plus positive is going to give you positive. This is your natural numbers. 7 plus 4 is 11. But -7 plus a -4 is -11. Like saying you spent $7 on your credit card, so you owe $7. Okay? And then you spend another $4 on the credit card. How much do you owe? How much are you in debt by? You are in the hole by $11, right? -7 plus a -4. You can draw these examples on a vertical line so that you can see as you move down. Here we have 0. And let's say I add -3, I move down -3. You see that? Okay? -3. I move down -3. And then I add another -2, so I was at -3 from 0. I'm going to add another -2, and it goes all the way to 5. That's a great visual. And you can see how -5 is -5 right there. Okay? Now, find the -26 plus -27. Again, you go to the mall, you spend $26 on your credit card, and then you spend another $17 on your credit card. You're going to be -43 in your credit card. That's a lot of money you're owing. Let's try A, B, and C. Okay, so A, you have -5 plus -7. It's going to be negative, right? Because they're 12, right? Again, think of it as money. You spend $5 and then you spend $7. You have spent $12. You have 12 less dollars than you normally have. Again, you have here you have -10 plus -4 is -14, and then -14 plus -16 is -30. Okay, boys and girls, if you're not pausing and then checking your work to see if you have the correct answer, you're not challenging yourself, and therefore you're not learning. So make sure you pause when you see these questions and then play to check your answers. Add integers with different signs. To add integers with different signs, subtract their absolute value. The sum is positive if positive integers' absolute value is greater. Negative if negative integers' absolute value is greater. So clearly, here we have a positive that's bigger than the negative, so the difference is going to be positive. Here we have a negative that's larger than the positive, so the difference is going to be negative. That's another way to look at it. Again, if you feel like I'm going too fast, please pause, rewind, and listen to me explain it again, and maybe it'll make more sense the second or third time you listen to it. Okay, please take some time to look at example, I believe it's example 3. Look at it carefully so that you can see how the numbers shift. First, look, you can see that we have 5, goes all the way to 5, and then we have -3, so it finishes at 2. Okay, here we go with -3, but then we add 2, and it comes back to -1. Let's try these down here. Okay, so I have 6 plus -7. I have $6, but I spent 7. I end up owing my credit card $1. So I'm negative $1. Okay, here I have -15. Oh my goodness, I'm already in debt by $15. But then I do a little bit of work and I make 19. I pay off my credit card. How much do I have left over? I will have 4. Okay, I hope this is making sense, boys and girls. Like always, please take a look at examples. Oh, I did that again. Examples 5, 6, and 7. Okay, look at it carefully, read it, take the time. I really just want to try the examples on the bottom of the page. So what I'd like to do is right now, after you've read the how to do it, the examples, try these right now on your own. Try them. Pause the video now, please. Pause. Okay, I hope you paused the video because now I'm going to check. So I have positive 10 plus negative 12. I have $10 and then I spent 12. I spent 2 more than I had. So I'm going to owe 2. I have -2. I owe $13, right? I owe $13, and then I make 18 because I worked so hard. So I pay off the 13, and how much do I have left over? Right? How much do I have left over? 5, right? And then let's see, I spend 14, I'm indebted by 14, and then I spend another 6, so I'm indebted by 20, but then I make 6 back. Now these are additive inverse, boys and girls, if you haven't picked up on it. A negative and a positive. Those two cancel each other out. Because they cancel each other out, they don't do anything to our value, and we're right back to -14, which is all we have left. And finally, a real-world connection. How does this match with this roller coaster? A roller coaster starts at point A. Okay, point A. I'm assuming it's a height. It goes up 20 feet. Okay, so it goes up 20 feet. Let me just do it up here. So we have 20 feet that it's going up by. I could put a plus sign on that if I want to. Then down by 32 feet, and then it goes down by 32. Okay, and you remember, and -32 down by 32. Okay, hope that makes sense. And then up 16 feet, and then 16 feet up, right, to point B. Write an addition and subtraction. Okay, well, I just did it right there for you. I wrote an equation, and look, there it is. I hadn't even looked at this yet. And it's going to equal 4. Of course it will, because 20 with -32 is going to be -12. Difference here, -12 plus 16. It's going to give me 4. There it is. Okay, let's try I together. And we're talking about temperatures again. Quite common when we're talking about integers. The temperature is -3. An hour later, it drops 6. Drops means it goes down. So I'm going to start with my -3. And then it drops by 6 temperature. And 2 hours later, it rises again by 4. Goes up by 4. Right? An addition expression to describe. Now remember, it's an addition equation. I'm adding. Okay, I'm adding. So -3 plus -6 is going to be -9. These two right here gave me -9. Okay? But then I'm going to add a 4, and it's going to bring me all the way back down to -5. Alright, I hope you get that. So find the sum and explain its meaning. Its meaning means that after all of these temperature changes, the temperature is going to be -5 Celsius. There it is, or -5 degrees. Here's the guided practice. Please leave this for class so that we can do it together as a warm-up and answer any doubts you may have. But I think you're ready to do the independent practice as you see right here. So please try the independent practice. If you have any questions, reflect on the video again. Examples 1 to 7 or example 8, which is the last one we just did. Go ahead and try it, boys and girls. We'll check it in class. Have a great weekend.